Hello, everyone, and welcome to this webinar. It's going to be this time about the best layouts in action, real challenges, and real solutions. I think people are still joining, so we can take some minutes to start, 2-3 minutes. And in this meantime, I can show you our webinars, maybe our next webinars, and also past webinars that we have in our in our website. As you can see here, we are today best layouts in action, real challenges and real solutions. This would be the webinar that we will be seeing today, but we also have different webinars. For example, next week, my colleague Hassan is going to make a webinar about navigating grid saturation, strategic planning for solar and BESS developers. And also in the start of January, we're going to have our product updates, what's new for Q4 of this year. So if you want to also check past webinars that we had, you can also go in our page and check them. For example, I recommend this webinar in here of my colleague Felix. It's about introducing the 3D energy simulations for precision solar yield estimates, which will cover this new 3D modeling engine that we have now in our software. And you will have also a lot of different webinars that you can watch, for example, about batteries, which is the hot topic right now. So we will also share the link of this page, and you can look it after this webinar. So going back to our presentation, let's see if more people are joining. Okay. I think we can start now. So this is a presentation of today, best layouts in action, real challenges and real solutions. As a little introduction, this is me. I'm Luis Vinco. I'm a technical advisor for the DACH market, so Germany, Austria, and Switzerland. And this is the agenda for today. So we're gonna cover how the best layout tool works in RatedPower, first of all. Then the best configuration types that we have inside of this layout tool. Number 3 would be the feature benefits of this layout tool. And then after this little presentation, we're gonna jump into the software and do a live demo building and comparing different layouts. So starting off with how the best layout tool works. This is our layout tool that you can see in the picture in the top right corner. And this feature allows users to easily replicate real world best layouts, for example. Just to give you a little information, I'm going to read these points. So the tool provides multiple predefined distribution and orientations. The most common industry proven layouts are available. So we have also a database, for example, with the PCS and the manufacturers, Tesla, Sungrow, and so on. You can choose also options that replicate your preferred manufacturer guidelines, define setbacks between elements to comply with local regulation. You can see also in this picture. And also we have now one of the latest updates, road configurations that can also be selected to adapt the layout for operational and maintenance, safety, and site access. And after all of this, we will see that you will always have the option to save the defined parameters as a template for future use and have your own templates for different manufacturers, layouts, and just by simply clicking on them, be able to use them in different projects. So let's go to the next slide, best configuration types. This is just like a little recap on some things that you will see now inside of the software. We have options, for example, about changing the layout inside of each BESS block. For example, the PCS and container arrangement, like you will see here in this little box here. You have the option to choose between parallel and perpendicular. Here's some little insights. For example, parallel PCS placement, like the one we see here, or in this other picture. It can have easier access for maintenance and cable routing inside the block, but it also can have potentially slightly larger footprint. As you see, if you compare both of these layouts, you see this one is taking more land or occupying more than this other one because of the parallel configuration. And the next one, which would be this perpendicular PCS placement, can potentially maximize space efficiency. If we maximize our space efficiency, we can get maybe a higher capacity inside our our area. But this also depends on the site, on the different batteries that we're using, just as a little overview. Next point would be orientation, in this case, not inside of each battery block, which consists of container and PCS, but general, like from the whole layout. So we have here different options. For example, you see we have same orientation, mirrored and back-to-back. And for example, a mirrored configuration could give you where the PCS face each other, like this one in here. Could help you to share trenches and to also shorter the cable runs. The roads would be, in this case, behind the battery containers, which would make an easy access for delivery, replacement, and emergency vehicles. This is very good because, you know, if you have to replace containers, you will need heavy machines. So having the roads near to our containers is always going to be helpful. And this can also reduce our capex in cabling and trenching. And yeah, you have to be considering also, as our PCS are facing each other, to have proper ventilation and clearance between facing PCS units to avoid thermal recirculation. So we will see we have also distances that you can define between the different PCS, having this in mind. Other very common configuration is this back-to-back configuration, which in this case, we will have our roads in the middle of two facing blocks. You see here, you have your roads between these two PCS, which will have a direct vehicle access for PCS operation and maintenance instead of for the battery containers. This is maybe less convenient access for battery container replacement or firefighting operations. So also having that in mind, maybe it's more useful to have the roads near of the containers, as you need more heavy machinery. As for the PCS, where you can maybe walk and do your maintenance, and potentially longer cable runs compared to mirrored layouts, as you're not sharing as much trenches as in this other layout. A little note, each configuration can perform better or worse depending on site shape, available area, access roads, safety distances, and local regulations. So this is not something that you can always copy paste. It depends always on the site, but we will see that the software is very flexible and will help us to create these different scenarios. Just here, 3 little points about the benefits of this feature. First of all, easy, so no more manual container and PCS placement. Choose from top industry layouts to save hours of manual work and speed up project planning and execution. Next point, compliance. So we define regulation compliance setback distances to minimize risks and reduce revision time. And lastly, it's a reliable tool, so it generates precise, reliable BESS layouts, SLDs, and more documents like listing of cables, bill of quantities, and so on, and match manufacturer requirements in just a few clicks. So that being said, with this little presentation, let's jump into the live demo. And here we're gonna see in the software inside of RatedPower, we're gonna build a BESS layout from scratch, first of all, seeing all of these layout options into action. Then we're going to test different configurations and see instant impact. So for example, try different common configurations of the most known manufacturers. And then we're going to compare mirrored versus back-to-back layouts in real time and export lastly our documentation. So I'm just going to see if everything is okay right now. I see we already have some questions. Yes, this presentation is going to be recorded, and we will share the presentation. And the other questions, we're gonna have 20 minutes at the end to answer them. So let's go back into the software. And here we are in the software. So as you know, this is RatedPower. It's a cloud-based software, and we have different types of projects that you can create inside of the software. In this case, we could make this demo, for example, with a standalone project, but I think it can be more helpful or just insightful to make it with a co-located project with PV, as we are also a PV platform. So I'm going to just jump inside of this one project. You're going to see we have the different designs for this project in here that we could, for example, compare. But let's start from scratch. I will create a PV design, in this case, co-located PV plus BESS design. And I already have my site in here. As you see, we have our substation in here. We have an area for our PV layout, and we have also an area for our AC coupled BESS. So as this this webinar is not going to be concentrated on the PV side, let's just upload our template of a standard a PV layout for Germany, which we can just select. Let's run our design, and then we are gonna start with a realistic layout for our PV site, as you can see here, and we can directly go into our BESS system and create our own layout. So for that, I'm going to go to this BESS tab in here, where we will select our equipment, and then we will go to the BESS layout. Things that we can do, or that you can see here, we already have a BESS layout, but this is just like a placeholder. This is a generic battery system, and now we will give our own one. So for example, things that we can give here, it's very classic. You go select your equipment. First of all, you would say if you want an AC coupled BESS or a DC coupled BESS. In this case, we have an AC coupled BESS. Next, we will select our PCS. So for example, let's say I want to have a 2000 kVA PCS, for example, ABB. I will select this one. I save it, and now it's inside of our project. And I also want to choose that I want to have one PCS inside of each of these green rectangles where we have our PCS and our transformer. So I'm telling to the software, okay, the power of my PCS, the whole PCS or of the transformer is going to be 2000 kVA. Next one would be the battery container. So in this case, I'm going to use a battery container to create a 2-hour batteries. For example, let's say we have here different manufacturers, CATL. I will apply it. And as we have a 2000 kVA PCS, let's choose this 4000 kilowatt hour container. And now we will be using this CATL, which the length, width, and height, it's all the real measurements of this container. So next step, now we have already our equipment, would be to tell to the software how much capacity I want to fit in my battery area. For example, I can see here my PV layout has 15 megawatts. So I could say, okay, I want to have maybe the same amount of power in for my batteries. So you see here very easily with 8 blocks of these, I would have 16 megawatt, which is more or less the same as my PV plant. And here I could lastly decide how much supply cycle I want to have. My C rate, for example, if I want to have 4-hour batteries, I would have 2 containers connected for each PCS and a C rate of 0.25. In this case, I'm going standard. I'm going for 2-hour batteries, and I'm going to run my design and see what we're getting. So this is just this generic layout. We didn't say anything about the distances, about the roads, and we're getting here a layout to minimize our cable length, with our output will be here. And we have our desired containers and PCS. But I think in this webinar, we're gonna always go for maximum capacity and try to fit as much capacity into our layout as possible. So let's go to this interesting part, the BESS layout, which is the next step, and now really go for, let's say, real layouts or layouts that you could have in reality. So first of all, I took the measurements of this ABB PCS. I have it here in my sheet. So the length of this PCS is 3.18 meters, and the width is 1.522 meters. And we're gonna, for example, go and try to replicate this layout in here, which is a CATL real layout, real plant, and try to make it also in our software. So what we see directly here is that we have, first of all, perpendicular a PCS to our containers. We can also define here the distance between container and PCS. And the next point would be the block alignment. So how I want to be my block to align. In this case, we can see they are mirrored. The PCS are facing each other. So I would take, for example, this option in here, and I could give here also different setbacks, for example, between the containers, between the different PCS, or between the backside of our containers. The software is going to give you also a layered orientation and try to maximize the capacity, but we can also change this and see different scenarios. And we will see here one of the last updates, we can also define our roads. So in this other layouts, we see we have roads always here between, I would say, 2 blocks or 2 rows of our batteries. So I will say, I will take these roads in here, which are vertical, and I will have them exactly 2 number of blocks between roads. Lastly, for example, for fire protection, I could define in here different setbacks between my containers or my battery blocks and the perimeter, also in the fence and between the roads. And I will run my design again now with these changes. So I'm gonna try to maximize my capacity on this land, and I'm gonna also have this new layout, a CATL layout. So in a couple of seconds, I should see some insights into the layout and also into the capacity of our BESS. Gonna check if everything is okay. I see there are a lot of questions. We will see after in 10 minutes and answer all of these questions. So we see here we have our CATL layout, and it looks pretty much similar to this other layout that we saw, this real Texas CATL BESS. And we, for example, could have now the documentation and just download our layout. So if you wanna go here, I would go to my BESS general layout as a PDF, just to see also, for example, the width of our roads. And we would see here how our layout is looking like. Perfect. So I'm gonna close this. So the idea of this this webinar is also to compare different layouts and to have or to know how we could save our layouts in order to use them in other projects. So let's say this is our standard CATL layout, and we want to use it in other projects. First of all, what we can do is go here and save it as a template. So what I could say here is I save it as a template. It's going to be a CATL plus ABB layout, which with a mirrored configuration. And I can say here in my notes, these are, for example, 2-hour BESS. I would save it. And now in future projects, I will have always this template, and I don't have to start from scratch. So I can just use it and have this layout from the beginning. Other things that you could do now is see what the software is telling me about this layout. So it's telling me I have here 378 megawatt in my site. Things that I could maybe change is the orientation of the layout. So the software is recommending me this because it's adapting to the site. But maybe in this case, using a horizontal layout or orientation would be more beneficial. So let's see. We're going to try and compare it with a horizontal layout, and let's see if we get more BESS rated power. And you can just easily jump from one layout. So the first one, 61, design number 61, to the next one. And we see in this case, we are at the same rated power, but it's all being orientated in another way. And just lastly, we could also try with a vertical alignment. And you see it's very easy to do changes and to see real life impact on the plant. So this would be, for example, the vertical alignment. And you see the first two layouts got more rated power than the horizontal one. So now the idea of this webinar is also to create other designs and also with other manufacturers. So instead of now going and, for example, I could just go to the BESS, choose my battery container and go, for example, for a Tesla container, which are, oh no, sorry, I'm not comparing this Tesla. I'm gonna compare a Sangro container. We could just directly use a template. So I will go here, template, load template, and we will see we have different templates that are saved for us. For example, we could go and start with the, let's see, with a Tesla template, exactly this Megapack, which is one of the most common used Tesla BESS systems or battery systems, and we can just select it. And I will expect now to run my design and have a completely new layout with new batteries. And in this case, all of these new layouts are going to be 4-hour batteries, which I want to compare because I want to have, in this case, 4-hour BESS. So you see, we would have here a completely different layout, which would be something standard for Tesla. For example, if we see this other existing plant, you see we always have 2 containers with the PCS in the center and then other 2 containers, and they are always with different roads going through each row of batteries. So if we go back, we will see we have the same layout in this case, and the software is telling me, okay, you are now fitting a rated power of 320.76 megawatts. So let's compare this one with other Tesla, same battery container, same inverters, but other configuration. So for example, what I could do is just the same. I load my template, and in this case, we were using this Megapack version 1. We will go now for a Tesla Megapack with other versions. So instead of having our PCS in the center, we will run our design, and we will have now a mirrored configuration with our containers being, as you will see here, 4 containers in each side. So this is another Tesla common layout, which I think I have opened in here exactly. And you see these ones are, the PCS are no more in the center of these 4 containers, they are on the side, and they are facing our roads. So in this case, we have the same configuration, but what is facing our roads are the containers and not the PCS, because we have a mirrored configuration. This is maybe, as we were talking before, more helpful because if we have some problems with our batteries, having our road near to the battery containers is going to be easier for the heavy machinery to replace them. But let's just recreate the one that we saw before in the picture, and and use the other template, which would be our Tesla Megapack. This one, back-to-back version 2. I select it, I run my design again, and now we'll expect our PCS to be facing the roads like we just saw on this picture in here, this real Tesla plant. So as you see, it just changed. I guess the rated power didn't change much. Now we are at 364.32 megawatts. Before we were at more. So the software is telling you, okay, with this other configuration and the side of our plant, you will fit more capacity. And just to go through another and the last layout that we're going to recreate in here, let's just change from manufacturer and choose a Sungrow, which is also very common use. Sungrow Power Titan, I'm sure you all know about these batteries. As I'm saying, these are all 4-hour configurations. So let's go with the back-to-back Sungrow Power Titan. And this is going to be a completely different configuration, which is also very used in Sungrow applications, Sungrow BESS. And in this case, for having to have a 4-hour batteries, instead of having 4 containers connected to each PCS, we are going to have 2 containers, and they're going to be placed with this different layout. So you will see, in this case, we have back-to-back, we have parallel, and we have this vertical side PCS. So now we have a completely different distribution, and we are seeing now directly that we're having a much higher BESS rated power in this side. So we could maybe say, okay, maybe for this side, if we just are focusing on the rated power, our Sungrow configuration fits better. And lastly, let's go with the last Sungrow configuration. As you're seeing, if we go to our BESS, we will always be having here the right containers and the right PCS with its dimensions. So as I was saying, let's just do the last comparison and select from our template this Sangro mirrored configuration, which will be here. And then, as always, run our new design and see from all of these configurations which one is giving us the best results. We see directly we now dropped away. Why? Because in this case we are having a different configuration, which will be, instead of back-to-back like this, mirrored, and for some reasons we're not going to have the same capacity in this layout. You will see the impact right now. So we were at design number 67 with this back-to-back layout. Now we are at design 68 with this mirrored layout, and we cannot fit the same capacity. We have less battery blocks because of the shape of the site. So what we could do now is just save the different layouts and see them in our project folder. Little recap. What we do configuring our sites, we select our equipment in this BESS tab. We select our containers, our PCS requirements, and then we go to the BESS layout and we can configure how we want our layout to look like. We have a Sangro layout in here. We have another Sangro layout back-to-back, which has the maximum rated power 407.5 megawatts. Then we were talking about the different Tesla layouts that we have here. All of them are 4-hour batteries, and our CATL layout. So this is pretty much the most important part about this BESS feature, layout feature that you see. It gives us much more flexibility to create different scenarios, and very important to save our templates and use them in future projects, so you don't have always to go with this manual work. And for example, in AutoCAD, copy paste, try different scenarios. You can just do it by following this workflow and clicking on this Run Design button. So now we are 11:27. It's time for the different questions, and we see we have here different questions. Let's see. I'm gonna just answer them directly. New BESS applications, multiple battery areas. Okay, so you're asking about the new BESS applications and of the software. So for example, this is a good question. We showed a lot of new applications that we have in the software, all of these layout applications, but we have also different updates. For example, something that we didn't show here is the option of having multiple battery areas. So it is possible to go to our location, clone our location, and just simply, for example, change our complete site. So I could say, I want, for example, to have a completely different site. I want to move this edge in here, or also remove different points. And I could also add a new battery area. So just as a little example, I could tell this is my battery area and have different areas in my site. I'm just going to go here, battery area, rectangle. And let's say I want to have 2 areas. So this would be also something possible. For example, if you want to avoid the overhead lines and you want to have different layouts, you could have different battery areas inside of the plant. Let's go back. And about other updates, this is much an update that was some months ago, but maybe interesting just to mention it. We created now layouts, we created different scenarios, and we have information about the best rated power and the best capacity, but we didn't run any energy simulation or energy model for the batteries, but this is also possible. So if we go to our batteries, we always have this dispatch option in here. If we activate it, we will have more information that we can give to the software, for example, about the efficiency of the batteries, about if we want to have 2 different types of batteries. In Germany, you call them green batteries or gray batteries. So can the battery system charge only from our PV side? Would be like this. Or if we enable this, it can also charge from the grid and from the PV side. And then we can define maximum, minimum state of charge, maximum cycles per day, and also our degradation. If we have this activated and we go to our financial tab and define also a type of revenue, let's say, for example, a variable price, where in this case, this location or this plant is based in Germany. So we're going to have our database, the day ahead market prices from last year. And I run my design. The software or the algorithm of the batteries is going to take the different prices of the market into account, the prices of my production. So for example, if I have curtailment, if there are negative prices, and do arbitrage to maximize our profit. So now we were seeing just these results before, but now we will have much more information in here, like how much energy was charged from the PV side, how much was consumed from the grid, discharged to the grid, our average daily cycles, recovery curtailment, and so on. And we will have also different documentations for our system. So I would say these are the most important parts. Another feature that we just launched is also for the standalone projects. So you can create battery standalone projects, having also interconnection facilities like switching and breaking stations, substations, and dimension also into high voltage. So let's just go with other questions that we see here. Let's see. Okay, there's another question. What is the availability of products on the market for DC coupling? DC coupling as a standard solution for utility scale are currently AC coupled base inverters MV stations. Okay, so for DC coupling, as you know, now the standard would be in the industry the AC coupling, because it's more easy to retrofit existing PV plants. You can just put your AC coupled system and connect it to the bus bar. You don't have to go inside of the PV plant for the DC coupled. But as far as we know, manufacturers like Sangro, Tesla, BYD, they are creating now DC-DC converters with 2 to 3 megawatt of power, and but they are normally not that, or I would say they are not standard for the industry for larger plants like more than 100 megawatts. Let's see other questions. Jose Luis, hello. Is it possible to create zones with different equipment orientations on the same BESS plant? That's a very good question. It's a yes and no, because in the same BESS, so for example, in this area and here, I cannot select different equipment. What is possible is that I can, as we were seeing here, is create, for example, different designs with different equipment. So for example, if I want to fit in here, let's say, 2 different parcels of batteries with 2 different types of equipment, what I could do is do one design with a smaller parcel, use Sangro, for example, do another design with the upper side of the parcel, and run a design here with, for example, Tesla. And then I could have 2 different designs with the different parcels having different equipment. Inside of the same parcel, it's not possible to have different equipment. And it goes the same with the orientation. What is possible is if we have different areas inside of the same design. So we have area 1 and area 2 to have different orientation, but they have to be with the same battery equipment. So it would be both areas with Sangro, for example, but one could adapt to one shape and the other adapt to the other shape of our site. Okay, there are a lot of questions I see here. Do you have a dispatch model for the BESS? Yes, we just talked about this dispatch model. I think it's all based on arbitrage. Okay, so Michael is asking, or Michael, sorry, is asking, hi, what is the usual capacity of a single PCS and BESS set? how many of these will do a 1.5 megawatt capacity? So I would say standard capacities would be, for example, Sangro in this power Titan that we were simulating. The PCS here, or the battery containers, they have a 5 megawatt hour, and they offer 2-hour batteries and also 4-hour batteries. So for example, for the 2-hour batteries, the PCS would be 2.5 or 2500 kVA. And for the 4-hour batteries, they would be the half as big, so 1.25 megawatt. How many of these will do a 1.5 megawatt capacity? So for example, with only one Sangro of these configurations, you will have a bigger capacity than this. You will have 2.5 capacity or power. Gautier, I don't know if I'm saying right your name, sorry, is asking, in the inverter PCS database, I would like to select SMA battery inverters, but only solar inverter were available. Will you shortly update the database with SMA battery inverters? That's a great question. As you know, now we are also sharing the PCS database or the inverter database with PV. And you're right. Good news about this: the next update or the next big update in our software regarding BESS is going to be about having a better database or a wider database. For example, having different configurations, like having the inverters inside of our containers, like all of these skids that are being used now, and also to have just a wider database with different MV skids, different PCS, and just more flexibility in this case. So you can expect in the next few months to have this update, which is going to be great for the designing of the different layouts. Okay, I see a lot of questions. I don't know if we are going to have time for all of them. Ayush is asking, is it possible to have multi-market evaluation for BESS energy dispatch? That's also a great question. As we were talking for now, the only algorithm that our battery follow is arbitrage. So all of this information in here, energy charged, energy discharge, is going to be based on maximizing our profit, looking at the profile that we have on our database, in this case, stay ahead market prices, or on the different energy prices that we upload ourselves. But the option of having different markets, for example, or different dispatch strategies like frequency regulation, peak shifting, or other options is not possible for now. But we will also have implementation in the near future of, for example, having the option to not only let the software decide when to charge and discharge based on arbitrage, but to give different hours of charging. For example, tell to the software, I want my batteries to discharge in the nights and charge in the days. This will be possible. Different markets, this is something we are also looking at. I would say this is something for a wider future. But yes, you're right. And right now we do the arbitrage. If you upload, for example, intraday market prices, it will be the same, but for this market. In this case, we uploaded day ahead market prices, and we're just focusing on this one market. Okay, there's another question. Kavla is asking, is it possible to define more than one parcel for the same BESS co-located project, like defining 2 or 3 plots with the PV area? That's right. This is possible. You can define different battery areas for co-located projects. This is not for co-located projects. Okay. This is going to be in a next update. For now, it's possible for standalone projects, so you can define different areas, up to 30 battery areas, and the area has to be always smaller than 40 hectares. But exactly, this is possible for standalone and will be now in the future for co-located projects. What we have now available for co-located projects, which was a new update, is that you can put also the battery area inside of the PV plant. So now in this case, we have it outside of the PV plant, but it will be possible to have it inside of our PV plant also. Okay, I see a lot of other questions. What type of chemical batteries are used? So in this case, all of the batteries that we use, I would say all of them are the lithium-ion batteries, so LFP batteries. But the software is not looking at the chemistry, let's say, it's looking at the parameters that we are giving. For example, the efficiency, the degradation that we are giving as an input, or different options like the average cycles per day. And with this information that we give, power, capacity, it's going to do all the calculations. But I think in the market right now, most of them are LFP batteries. What are the environmental requirements for BESS installations? We have different requirements. For example, the most important, I would say, that are requirements for fire. For example, in the software, you can define setbacks, as we saw in the BESS layout. This BESS setbacks, for example, it's very important between our site and our batteries. Normally, I would say 5 meters, 6 meters are always a good option for this firing mitigation. And others would be maybe also maintenance, operating, so having the right distances or the right distribution of roads to have correct maintenance for our batteries. Also, some bigger plants or in some requirements, they have also this noise emission requirements, which you can, for example, have by moving away from houses or from different locations. I would say that would be the most important ones. Let's see if we can answer other questions fastly. Okay, ancillary services, they are not exactly as we were saying, ancillary services, we don't have them implemented, and the algorithm doesn't do this kind of helps, for example, frequency regulation or other regulations. But this is something we're looking for definitely for the future. And yeah, I would say, first of all, we will get other things like this bigger container or database, and then we will also focus on this other dispatch options, like revenue stacking. Lucian is asking, hi, do we have any cable routing, cable section calculation option? So yeah, we have this option. It's in the electrical tab. Here we will do all our cable sizing. In this case, we have a co-located plant, so we will have PV plant and batteries. But the idea of this is, first of all, select our electrical standard, in this case, this IEC for Europe, and then you select your maximum voltage drop. For our batteries now, important would be these lines that we see here in orange, which are the medium voltage line. So we would concentrate on the MV system. We give here our maximum voltage drop. And if we go here down to our MV cables, we can also select, for example, the cross sections that we want the software to be able to use in its calculations, the maximum numbers of cross sections to use, maximum circuits per phase, material, insulator, and core. And with all of this information, the software is going to do the calculations, adapting to the standard and to the maximum voltage drop that we gave. And we will have our documentation, for example, our listing of cables, which is an Excel file where we can see the different cross sections of the cables, length of the different cables, all based on this information that we gave to the software. I think we're running out of time, and there are some other questions, but for sure I will take them and answer them via mail. So thank you everyone for joining to this session. I hope it was helpful. I hope you saw the value of these new features, layout options, how you can create very easily different configurations, how you can also just save them as templates and then compare them. And exactly, I hope this was helpful. So thank you very much for joining, and we see you in the next webinar. Bye.